In this video, we want to continue to look at right triangles and solving right triangles. Now, if you remember what we looked at previously, we looked at solving a triangle like this. And we could label our sides as B, A. We could find our other angle here, 52, and then we'd use our trig functions to be able to solve for A and B. But what happens if we have a triangle like this? Now these aren't labeled, so let me just label them so we can talk about this. Let's say I label these A, B, C, and let's say we now want to find what's the angle. We have all the sides, we want to find an angle. So that's what we want to look at today, is solving for the angles. Now we're always going to be given one angle. These are always a right triangle, so we're going to know that we have that right triangle. But if we think about writing our trig functions here, and I'm going to use theta and let's use sine. So we could say sine of theta or A, whatever you want to use, is equal to 4/5. How can I find theta? Well, to do that, we're going to use a new thing on our calculator that is known as the inverse sine, and it's sine to the -1. Now, if you have a TI-83 calculator, you have your sine button here, and right above it you can see sine to the -1. So you hit second sine to get sine to the -1. This is on the calculator on your computer. It's on the calculator on your phone. It's on Desmos. If you go to functions and your trig functions, here is sine, here's sine to the -1, cosine, cosine to -1. So if I want to find theta here, what I'm going to have to do is I am going to say theta is equal to the inverse sine of 4/5. So I put that in my calculator, and that will give me my answer. So now this is how I find an angle. Anytime you want to find an angle, you always have to use inverse trig function, whether it be inverse sine, inverse cosine, inverse tangent. Let me show you on our calculator here. If I would take the sine of 30 degrees in my calculator, and I get 0.5, if I do inverse sine of 0.5, it gives me my 30 degrees. So this is a way to find the angle. So here, if I had sine, inverse sine of 4/5, this would be inverse sine of 4/5, which would give me 53.12. So my answer is 53.12. Now, anytime you do this, you only have to do this one time, because once you find that angle, you could then find this angle by subtracting from 90. Now, many times when we do these, we're not going to be given all three sides. We're only going to be given two sides. So first, let me find angle B. So I can find angle B by saying cosine of B is adjacent over hypotenuse is 6/15. So my angle B, I am now going to use the inverse cosine, which is cosine to the -1 of 6/15. Now let me do this on Desmos. Now if you're using Desmos or you're using any calculator, you want to make sure on Desmos, it's up here with the settings, you want to make sure you are in degrees. That's always important that you're in degrees. So we have, go back, cosine of 6/15. So I'm going to go here, function, inverse cosine of 6 divided by 15, and I get 66.422, which is the same thing if I would do it on the calculator, inverse cosine of 6 divided by 15, 66.422. So that is my angle B, 66 0.422. Now, once we know that, we then need to find my angle C. And to find my angle C, I can just subtract from 90 and get 23.578. And the last thing we need to do is we need to find this side B. Now, at this point, we have a whole bunch of different ways we could do this. We could use our trig functions. Let me show you that. I could say the sine of B, which I don't need to say the sine of B. I could actually say the sine of 66. So I could say the sine of 66.422 is equal to B over 15. And like we did this before, 15 times the sine of 66.422. And if I put that in the calculator, 15 sine of 66.422, I get 13.748. Now, so my B is 13.748. Now, you may be wondering, could I have just done Pythagorean theorem and said 6 squared plus B squared equals 15 squared? Absolutely. Let me show you what happens there. If we do that, we have 15 squared, then we'd be subtracting 6 squared. We'd be taking the square root of that number, and we get the exact same thing. So really, you only have to use your trig function one time. Realistically, we could have not done it this way. Okay? We could have just used Pythagorean theorem and one inverse, because once you know one angle, because of the 90, you're going to automatically be able to find the other. Let's look at another example. So we want to solve this. So first thing, we need to find side C, and we could do that just with Pythagorean theorem. 9 squared plus 14 squared equals C squared. So if we put that into a calculator, we have 9 squared plus 14 squared. We take the square root of that. Take the square root of that. And we get 16.643. Now, we need to find one of these two angles. Now, because we know all three sides now, because we did Pythagorean theorem, we could use any angle we want. Now, I'm going to use one I haven't used yet. I'm going to use tangent. So I'm going to say tangent of A is 9 over 14. So A is inverse tangent. This is all writing these out, putting them into the calculator. This is second tangent, 9 divided by 14. I get my answer. I subtract that answer from 90. So I get 32.735. And then my other angle is 57.265. So there we have solved for all of the angles and all of the sides. And once again, just like last time, there will be some problems where we need to draw the triangle. Once again, don't worry about drawing it to scale. Just draw your triangle, put the right angle in, label. We'll say this is 7, this is 11. So if this is 7 and that's A, the opposite side is side A. If this is 11 is C, then the opposite angle is angle C. We could do Pythagorean theorem to find B. I'm not going to do that. Let's look at finding angle A. So I am going to do tangent of A is 7 over 11. opposite over adjacent. So now we do inverse tangent of 7 over 11. So we put that into our calculator. Inverse tangent of 7 divided by 11. And we get 32.471. So this is 32.471. Once you find that, you can subtract from 90 to find this angle, and then you can do Pythagorean theorem to find B. So what we're doing is we are solving the triangle. Find all three sides and all three angles. And really, one is always 90, so you're only looking at trying to find those two other angles. So you're going to be doing Pythagorean theorem once to find B, and then you're going to be doing one inverse trig function to find one of the angles. You're now ready to do the homework. We are solving right triangles using SOHCAHTOA, and we are looking, not for the sides, as it says here actually, we are looking for the angles.